So some of your teachers will have taught it maybe a little different. However, you're going to see me factoring like this all year, and I'm going to tell you a little secret. My students can factor better than any students in the school. Teachers might have taught you differently, but you're going to see me factor like this all year, so I suggest learning it like this, or at least seeing it like this. And if you do it my way, you're going to be really good at factoring. Okay, so here in general is what we're going to be looking at, factoring. So these are the steps you should probably take. You're not going to be able to take notes on every little thing, but just take basic notes. Okay. When factoring any polynomial, the first step you need to look for is it in standard form? Now remember, standard form means highest degree to lowest degree. So if you look at this example, degree 3, degree 2, degree 1, and then our constant, so it's in standard form, highest to lowest degree. After it's in standard form, if it's not already, then you would second check, does it have a greatest common factor? We would always want to factor that out first if it does, because sometimes that makes the next piece of factoring easier. So here's a basic example. The greatest common factor is a 2, so we pull out a 2. Correct, everybody? In both of those terms, there's a 2. Divide by 2, divide by 2. So the one left would be x minus 2. So just saying, greatest common factor, pull it out. Then third, we're going to review, you've got to be so awesome at factoring a quadratic. So if it is a quadratic, that means it's degree 2, you check. Can I quick factor or long factor? Now this is kind of Miss Christensen's slang words. You'll see what I mean though. Sometimes you can factor this super quickly, and then sometimes you have to do the long factoring and you have no choice because it just doesn't work the quick way. So here is when you can quick factor. We'll see examples in just a second, but you can quick factor if and only if your leading term has a coefficient, which means number in front of the variable, positive 1. That is the only time you can quick factor. It has to be positive 1. You would have to long factor if your leading coefficient has anything other than positive 1. Make sense? Okay, awesome. So let's review how to quick factor, and then we'll do some long factoring ones. Okay, so like I said, here's how we can quick factor if our leading coefficient is 1. Must be positive. So here's my first example. I'm going to scroll up for people in the back. Okay, we're going to factor this. So the first thing, remember quadratics, I wrote up here, quadratics have the form ax squared plus bx plus c. So look right here, that's positive 1, a is 1, b is negative 12, and c is 36. Is everybody good with that? A, B, C, coefficients. So then from there, here is our first step we do, and this is always what we do when factoring any type of quadratic, even long factoring. This is still the first step. We do what multiplies to be a times c. So I set up a chart. I set mine up like this. What multiplies to be a times c, which is 1 times 36. So what multiplies to be 36 and adds up to be b. So I'm going to write in the b here. So now we're going to list out the factors. Let's say you didn't know right off the bat. This is the best way to figure it out. List out all the factors of 36. Factors mean what multiply to be it. 1 times 36, participate, and the lesson goes 10 times quicker. So tell me another one. If you're wrong, that's great because you're better than the people that are still silent. Yes?
6 times 6 for negative 6 times negative 6.
Okay, true. Okay, so for this one, so for some people, I'm just going to show them how to list it all out. So you keep going in order. So what's 2 times what equals 36? 18. Now let's look here. Could 1 and 36 ever add up to be 12? No. How about 2 and 18? No, so we keep going. 3 times what? 12. Well, that obviously doesn't have to be 12. Moving on. 4 times. And then we keep going. I'm just showing you. This is how you list it out. Everybody good? Okay, so now we get to 6 times 6. Oh, couldn't that add up to be 12? It needs to add up to be negative 12. So wouldn't we put a negative on both? Negative 6 plus negative 6 is negative 12. Now here's the thing you got to check. Does it work in both situations? Does negative 6 times negative 6 equal, it has to be positive 36. Yes, and it also adds up to be negative 12. Therefore, we have found the correct factors. It has to work in both. You have to put check marks on both. Okay, now because we can quick factor, this is what you'll do. You'll put in your parentheses, and you'll throw in your variable x and x, and then you can insert those right in because we can quick factor. So minus 6, because there's a minus 6, minus 6, because of that minus 6. And now look, we've factored it. And look, we know that factoring is the opposite of multiplication. We've peeled it apart. But look, if you put it back together, do you see how we end up back at the top? Multiply it back together in your head. All good. Okay, awesome. You can quick factor pretty easy. Let's do another one, but this one don't take notes. Because now you see how easy quick factoring is. Just watch, we're going to go quicker. What multiplies to b? Well, we can quick factor because of the positive 1. What multiplies to be a times c adds up to be b. So isn't that 1 times 54? Yeah?
Yes.
And b is 15. So now, we don't need to list them all out if we can see them. But let's say we got to the homework and we're like, I don't know, do 1, divide by 1, 2, 3, list them all out. Does that make sense? Here we go. What times what equals 54 and adds up to be, could add up to be 15?
6 and 9.
So you're saying 6 times 9 is 54, and then it could add up to be 15. Okay, true. Now it needs to be positive 54 and positive 15, so wouldn't they both stay positive? I didn't mean to write 6 plus 6, but yeah? Both positive? So those are our two factors. We can quick factor, so let's throw in our parentheses, ding, 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 x, positive 6 plus 6, positive 9 plus 9, and done. We can check it by multiplying back together. Easy. Yeah? Okay. How many of you, your teachers taught like this? Okay, that's great. Oh, I guess. Yeah, okay. What multiplies to be a times c? Look, a times c, we can quick factor, and adds up to be b. B is 6. 4 times 2, both positive. It works in both cases. You gotta check, gotta make sure it's gotta work in both. It can't just somewhat work and then work over here. It's gotta work perfectly. Factor a plus 4 plus 2. You guys get the picture, yeah? Okay, I'm just gonna show you one quick thing. So this one throws people off. A lot of you know a trick, but I'm just gonna show you how you can still just look at it as quick factoring. Notice, there's no middle term. So this is the same thing. Look, x squared plus 0x minus 4. Do you see how it's the exact same thing? Yeah. We're missing the x part. So now you do what multiplies to be a times c and adds up to b is 0. Do you see how it's no different? 2 times 2, true? Yeah. One of them would need to be negative. Now look, that is negative 4, and then that is truly 0. So those are our factors. So it factors be x minus 2, x plus 2. All good? Yeah. Now that makes sense because look, opposite signs makes the middle term cancel out. Think about it. If one's positive and one's negative, they're going to cancel out, right? It's called a conjugate. Conjugate means change the sign in between. Okay. Look at this one. Can I quick factor it right here, right now? No. Now look, we have a negative in front. That's not positive 1. So what we would want to do first, if you ever see a negative in front, ever, factor out the negative. So I'm going to pull out negative 1. When we factor something out, we actually just divided it out. So let's go and divide it out and see what's left over. So in the first term, wouldn't it be x squared? Yeah. Positive divided by negative. And then you'd say, okay, cool, I did my first factoring piece. Now I have a quadratic, and didn't we just factor that quadratic? You'd keep going. You'd continue the inside. You see what I'm saying? You'd ignore negative 1 for a second, and you'd continue to factor that. And that factored to be x plus 2, x minus 2. That was the same problem as above. And then we'd say, oh, but also there was a negative 1. There's our answer. Make sense? Yes. Okay, that's factored completely. Means nothing else can factor. Cool stuff. All right, practice some of those. 5, 7, 9, 8, 10. These are off the homework. So you're jumping all around. That's just kind of what we do sometimes. Now, I need you to understand. Okay, I can't stress enough how you have to be able to long factor like a maniac. Like you can't get around it, okay? Long factoring always works for a quadratic. It works even instead of quick factoring. However, quick factoring we use because it's quicker if we can. If you quick factor when you can't, you'll get it wrong. So look, our leading coefficient, if it does not have positive 1, we have to do what's called long factoring. These are the steps we take. So watch, and then we'll get faster and faster. This is the best way to do it. It always works if it factors. Okay, so if you notice, this has a 7, a leading coefficient of 7. We can't quick factor, we got a long factor. So our first step is the same as quick factoring. We would do what multiplies to be a times c and adds up to be b. Let's start there. So 7 times 1 is 7, true. And adds up to be b, which is 8. Same first step. Now we're going to figure out the factors, same as before. So this one's pretty straightforward, isn't it? 1 times 7, and then 1 plus 7. Okay, it works in both cases. So now what you're going to do, this is new. You have the long factor. The next step is what I call drop and break. Drop and break. So what you do is you drop down the end terms exactly as they are. So look, here's an end term. I drop that down exactly as it is. I drop it down exactly as it is. That's positive 1. Does everybody see? Drop breaking. Now what I mean by that, everybody look, direct your attention. Do you see an 8? That's relating to that 8. It has an X, so put an X on it. Well, then these have to be X's. You guys see what I'm saying? X, X. So you're breaking down the middle term. You're rewriting that 8X as these two things we chose. Does that make sense? Order does not matter. We can put the 1X first or the 7X first. Doesn't matter to me. What do you want to put first?
1X.
Okay, sure. So plus 1X and then plus 7X. So I broke down the middle term. Guys, this is no different than this. It's just rewriting it in a way we choose based on this. Now what you're going to do after drop and break is, because there's 1, 2, 3, 4 terms. We always do this when we have 4 terms. The next step is factor by grouping. So you group the first 2 terms and you group the second 2 terms. Now notice something interesting. I grouped the sign with this sign in with this group. I always do that. Is everybody good with the grouping part? Now what you're going to do is focus on each group. Let's focus on this and factor out the greatest common factor. What's the greatest common factor?
X.
Pull out an X. Now when we pulled it out, what we technically did was we divided it out. So you got to write it and then go back and divide it out and see what's left over in each term. So what's left over in this first term? 7X. Good. And then right here?
1.
Yep, plus 1. Good. Moving on. Next thing, we're going to look at the next group and pull out the greatest thing in common. What's the greatest thing in common? 1. Don't be that person that says 0 and writes up nothing right here and just does another parentheses. That doesn't make sense. You have to factor out something. It's a 1, not a 0. It's a 1. So we're pulling out, I'm going to write it like this. We're pulling out positive 1, are we not? You're always going to pull out whatever that sign is. Now, if that was negative, we would definitely pull out a negative always, because that's in front a negative, but it's not a negative. I was just saying if it was. Okay, so we're pulling out positive 1. Divide by 1, divide by 1. Left is 7X plus 1. Everybody good? We're not done, but I'm going to point something out. At this point, you can know you've done it right. Here is why. This will always happen if you have factored it correctly. If you made an error, this is where you'll catch it. Inside your parentheses must be the exact same. No difference in sign or anything. If so, you've either picked the wrong factors, or you've messed up somewhere, or it doesn't factor. All of ours will factor, so you can know I did something wrong and start over from here, or go figure it out. Okay, now understand something from here. This is what I call like my safe haven, because I'm like, whew, I've done this right. So you're going to hear me say the safe havens. In the parentheses is always the same. Okay, this is a term, guys. Terms are separated by plus or minus signs. This is connected by multiplication. Do you guys understand that? Then this is an addition sign, so now here's our second term. So what you're going to do is now factor it one last time. In this term and this term, isn't there a 7x plus 1 in common? Pull it out then. Factor it out. So then what happened was we divided it out actually. When you factor something out, you're just dividing it out. So then look, it divides out. Left in our first term is a x. Look, it divides out there. Left in our first term is a, yep, plus 1. And we're done. Now you can look and say, does anything more factor out of any of those? No, we're good. Okay. Guys, this always works. It felt long at first, but because we went really slow, you'll get fast at this. This always works. That's awesome. So even with long factoring, you can do it with quick. You can do this instead of quick factoring. It always works. Here we go. Let's go again. We'll go a little quicker this time. So you say it's a quadratic. It cannot quick factor, so we've got to go through that whole process here. What multiplies to be a times c adds up to be b. So that times that. What is that? Negative. Yeah, I think you're right. Awesome. Negative 42. Thank you for the help. Okay, and then our b is positive 19. If you couldn't figure out the factors, you'd start listing them out. You'd go 1 times 42, 2 times 21, right? Okay. Sweet. So one of them needs to be negative. Which one needs to be negative? Now look, it needs to have to be positive. Positive 19.
Negative 2.
Good. Yep. And then you got to check. Is a negative times a positive a negative? So we really are good. Because sometimes it'll be a little off and that's not right. Does that make sense? Okay, and then negative 2 plus 21 truly works. Okay, let's drop and break. Here we go. Drop the n terms down exactly as you see them. 3p squared minus 14. Drop and break. Now remember, where is this relating? Right there. But there's a p on it. A p. Order doesn't matter. However, let's think smartly about this for honest kids. We want to do the easiest factoring possible. If I put the minus 2p first, that would be fine. However, that's not easiest because look, those 3 and 21 divide out perfectly. And I'm going to put 21 first. So plus 21p, and then I'm going to put minus 2p. You would still get the same answer though, either way. Now we're at the step where we group the first two terms. We group the second two terms, factor each group. What's the greatest thing in common here?
3.
And a p. Awesome, you guys are great. 3p, divide by 3p. Do you see how I have to write it? But that's because it helps. Parentheses, 3's divide out. P's divide out and become a
P.
P. Hey, you guys are awesome. I like this class. This is way better than the first hour. No, we're going to be watching the video. 21 divided by 3. Plus 7, because it was positive, and then our p's are gone. Moving on. What should I pull out here?
Negative 2p.
He says negative 2p. You're awesome because you remember to pull out a negative. I like it. Pull out negative. Divide by negative 2. Divide by negative 2. Left is, look, divides out, becomes a p. Becomes a positive 7. Safe haven's the same. We're good. So let's factor that out. Pull out p plus 7. We're at our last step, right? Divides out. I'm not going to write that out every time like I did last time. I was just showing you. So then left is 3p minus 2. Woo! Way quicker. That always works. It's not that hard, right? It's just remembering the process. Okay, sweet. I'm almost going to let you go. I just want to point out one thing. We don't need to do that one. This one. Okay, you can do this. I'm going to show you. Don't take notes here. I'm going to show you a trick in a second, but I'm going to show you how you can do it with long factoring. But I'm going to go quick, so just watch. Let's get more. This is the same thing as 4x squared plus 0x minus 9. True?
Yes.
Well, multiplies to be a times c and adds up to be b, which is 0. Isn't it 6 times 6?
Yeah.
1's negative. Okay, that really does work. So now I drop and break. 4x squared minus 9, break. Insert those in, but with x's, and it doesn't matter order. So I'm going plus 6x, and I'm going to go minus 6x. And then we factor by grouping. I'm just showing you how it works. Pull out a 2x, true?
Yes.
Pull out 2x, divide by 2x, divide by 2x. Then left is 4 divided by 2 is 2, true?
Yes.
2x. And then right here is a positive 3 because the x's are gone, yeah? Right here I'm going to pull out a negative 3 because of the negative in front. Negative 3, so I go divide by negative 3, divide by negative 3. So then right here becomes a positive 2x, and right here becomes a positive 3. I've done it right because look, so I pull that out. 2x plus 3, and then 2x minus 3. Whew. Whew. Now look at something. The signs are opposites, which makes the middle term cancel out, you see? That's helpful. Now what I want you also to notice is, you did learn in Sec 2, honors how to do this quicker than that way. That works, but that's really long. We have the two perfect squares here. What I mean by that is if we take the square root, it comes out perfectly. So what's the square root of 4?
2.
What's the square root of x squared?
X.
And what's the square root of 9? Not the negative. What's the square root of 9? 3. Well, look at our answers. 2x and 3, 2x and 3. Do you see it? And now you'd say, well,
Minus 3.
yeah, we need it to cancel out the middle term. So we need a positive and we need a negative. Does that make sense? Okay, cool. So, just a quick question for you. Could I quick factor this one?
No.
Ish. So the negative we need to pull out, right?
Yeah.
So we'll pull out negative 1. Then left is 4x squared minus 9. Everybody true?
Yeah.
Now should we use that trick?
Yes.
So we just learned?
Yeah.
So we have a negative 1. We already did it though. Square root of that, square root of that. So we have a 2x and a 3. A 2x and a 3. And then they're conjugates because the middle term's gone. Plus and minus. So all good? Now what if I just had this to start with? 4x squared plus 9. Well, multiplies to be 36 and adds up to be 0. 6 times 6, but 1 has to be negative, but this is positive. This does not factor. It has to be subtraction. Do you see why it makes sense? Yeah, it'd be I, but we'll get there later, not today. So we're just factoring what can be factored based on what we know. Hey, you guys get the picture? How would you rewrite this one? 25x squared, true?
Yeah.
Minus 4 because that's standard form. Remember first step. Then isn't this two perfect squares again?
Yes.
So it becomes 5x and 2, 5x and 2,
And then
plus and minus, and that's a multiplication sign. I just kind of spaced them out. All good?
Yeah.
Okay, I'm going way fast, but I want to give you some time to practice on your own. Okay, so some of these actually, if you look very carefully, they might look like long factoring, but you could make it quick factoring by factoring out something in common. So look at number 3. You could long factor it. Yes, that works. However, what could you pull out from the get-go? 6, and boom, now it's going to be quick factoring. Wouldn't you rather do it that way? Okay, so look for that in some of these. Okay, ready, go. You want to practice some with long factoring though, and I'm going to tell you which ones for sure are long factoring. Guys, if you need to watch the video on long factoring again, you got to do that. You got to know your stuff next time. Okay, here we go. So look, these ones you won't need to take notes on. They're super easy. If we have, the first thing we need to look for, guys, is the greatest common factor. Because you don't want to have to long factor unless you really have to, or, for example, or you might even not be dealing with a quadratic at first. So look at this one. It is quadratic, but we could do what multiplies to be a times c. Our c here is 0. We're not going to do it the hard way. Do it the easy way. What can we pull out right here, right now? 6a, so then you divide by 6a, divide by 6a, so then left would be an a, true? And then a minus b, and we have factored it. Let's look at this next one. It's not quadratic. Guys, how I just taught you is how you factor quadratics, degree 2. That doesn't just work in general, only for quadratics. So look at this one. It's not quadratic, but what is there in common? Pull out a 5x, divide by 5x, divide by 5x, divide by 5x. So left here is an x squared. Right here is a minus 6x, true? And then right here is a minus
8. Minus 8.
almost. I know, I did that same thing actually. I was thinking 40 in my head. You know, so yeah, okay. 16, cool. And then x is divided out. Okay, you say, cool, I did that. Now I gotta look, does it factor even more? Well, it's a quadratic. Luckily, it's quick factoring now. Do you see?
Yeah.
So you do what multiplies to be negative 16, adds up to be negative 6, because that's a times c, adds up to be b. Don't be lazy, guys, and just not write this out. Sometimes people do that. So 8 times 2, wouldn't it be negative 8? So this factor to be x minus 8, x plus 2, and then we'd say, but we cannot forget, we also have a 5x. Boom. Done. Good? There's our final answer. It's factored completely. Making sense? Okay. Now we're going to do factoring by grouping. Luckily, we already know how to do this. If there's 4 terms, everybody, maybe you should write this down somewhere. If I say to you factor, if there is 4 terms, you always factor by grouping. What I mean by terms are separated by plus or minus. So look at this example. 1, 2, 3, 4 terms. It is not quadratic, notice. So don't start doing what multiplies to be a times c. That's a quadratic thing. This is factoring by grouping because there's 4 terms. So grouping is similar to what we just did with long factoring, because we got to a point with long factoring where we had 4 terms. You factor by grouping. Group the first 2 terms, group the last 2 terms, just like we did with the quadratic long factoring later down the line. Does that make sense? So now you factor out what's the greatest thing in common here, just like we did before. 3a. So then you would divide by 3a, divide by 3a. Write this. Guys, I do these things because it's going to help you become an expert later. So then divide those out. So then we'd have an a squared. And then 15 divided by 3 is positive 5. True? Crapola. Crapola. What did I forget to factor out? Another a. Wasn't there actually an a squared in common?
Yeah.
Easy fix though. So you could say, okay, I should have done that. So instead, I'm going to put the squared there. So from a 3 to a divided by that would just be a. True, everyone?
Yeah. Yes.
Okay, so not a hard fix. And then right here, those go away, so we just have plus 5, period. Make sense?
Yeah.
Okay. Now right here, we're going to pull out the greatest thing in common, which is positive 7. Divide by 7, divide by 7. So then left is a plus 5. The safe haven rule is still the same. It's got to be the same. It is, or else we've done it wrong, or else it doesn't factor. Yours will all factor. Pull out the thing that's in common, which is a plus 5. So then it divided out, and it left you with 3a squared plus 7. Is everybody good? Now advanced thinkers would say, oh, Miss Christensen, there's a quadratic. We better check to see if that factors. Well, it multiplies to be a times c, which is 21, and adds up to be b, which is 0. And then you'd say, oh, 7 and 3, 1 and 21. Nope, nothing. So it doesn't factor. We're done. The quadratic doesn't continue to factor. Easy stuff. Factoring by grouping, I'm only going to do one more example that way. Here we go. So we factor by grouping because there's 1, 2, 3, 4 terms. So I group these 2 and I group these 2. I pull out the greatest thing in common here, which is 8x squared. Divide by 8x squared, divide by 8x squared. So then left is x minus 1. In common here, we would pull out negative 1, because there's a negative in front. You're awesome. Divide by negative 1. So then left is x minus 1. We've done it right. So we have x minus 1 we pull out. It divides out. Left is x squared minus 1. And then you can check again. Does that quadratic seem to factor? What multiplies to be negative 8 adds up to be 0. Nothing, right? 1 times 8, 2 times 4. Can't add up to be 0, so we're done. There's our answer. For sure. All good? Okay, cool. I don't think we need another example of factoring by grouping. Unless we look at this one and get a little frightened. No different though. 4 terms. Is there 4 terms?
Yes.
We factor by grouping. It is the exact same thing. Are you good? Do you want me to do it?
Good.
Good? Okay, cool. Awesome. Okay, so let's see though. Here's the thing. We're kind of cutting it short on time. I think we practice 1. Let's just have you practice 1. Go do 25. Because that's one like the one I just asked you if you could do it. So do factoring by grouping there, and then we'll move on. Okay, this is something called quadratic in form, which means it almost looks quadratic, but it's obviously not. It's degree 4, but it looks very, very similar to a quadratic in standard form. Like I'm going to give you an example. This almost looks like this. X squared plus 2x plus 1, doesn't it? And we know how to factor this lower one, correct? Yes, we can quick factor it, which is great. So what we're going to do is we're going to rewrite this in a way that maybe we can then, so it is actually quadratic in form. We're going to rewrite this like this. So isn't x to the 4th the same thing as this? X squared squared? True? Same thing, yeah. Raise a power to a power and you multiply. So we're going to write this, everything in terms of x squared. So this is actually x squared squared, like I said. Then we have plus 2x squared, that was already as is, and then plus 1. Now what we can do if we do it like this is we can go off to the side and we can say, okay, let's replace any x squared with a u. It's called a u substitution. So we're going to say, let u be equal to x squared. It's just a random variable I'm using, but I'll use u. So anywhere that there's an x squared, I'm going to replace it with a u. So let's rewrite it. There's an x squared. It needs a u. So that becomes u squared. Do you see? And then right here's an x squared, so that needs a u instead. So then plus 2, just u, plus 1. Okay, we know how to factor that. Let's do it. It's just a quadratic now. What multiplies to be a times c and adds up to be b? 1 times 1. We can quick factor it because look, our leading coefficient's positive 1. So this, its u's, factors to be u plus 1 and u plus 1 because we could quick factor it. Now here's what you're going to have to remember from there. Did everybody get that? Okay, we're not dealing with u's though. We just rewrote it like this. So instead of u, we need to go back and re-put it as our real variable, which was x. So u is x squared. So anywhere there's a u, you need to now go back and replace it with x squared. So this is really x squared plus 1, really x squared plus 1. There's your answer, but then you would check. Does this quadratic factor? So let's check. What multiplies to be 1 and adds up to be 0? 1 and 1, but 1 would need to be negative, which doesn't work, right? So it wouldn't factor because it doesn't add up to be 0. So we're done. Let's do another one with u substitution. Hopefully that kind of made sense. It's just a way to rewrite it in a way that will make it easier for us to see. Okay, look at it. X to the 4th, x squared constant. It looks almost quadratic. So we're going to do that same thing. You're going to say, okay, I'm going to rewrite this with everything with an x squared. So this is 7, and then it's x squared squared. That is exactly the same as that. And then we have minus an x squared minus an 8. So now everything's rewritten in the terms of the same thing, x squared. So now we're going to choose. We're going to go off to the side and say, okay, I'm going to let u be equal to x squared. Anywhere there's an x squared, put in a u. So right there's a u, right there's a u. So I'm going to rewrite it. We have 7 u squared minus u minus 8. And now I know how to factor it. What multiplies to be a times c and adds up to be b. multiplies to be negative 56 and adds up to be negative 1. 8 times 7, negative 8. True?
Yes.
Don't quick factor. It's a long factoring. Look, 7. Drop and break. I'm going to go a little quick through this step. We've already learned how to long factor. We're dropping and then we're breaking. I'm randomly going to put 7 first because this 7 is not random. So plus 7u, and then it looks like it's minus 8u. Factoring by grouping now, just like we always have been factoring our long quadratics. Listen to me with bad handwriting because I'm hurrying. So then left is u plus 1. Pull out a negative 8. Divide by negative 8. Then left is u plus 1. So then we factor out u plus 1. And left is 7u minus 8. There you go. You factored it. Now you would just say, but it's not u. U is actually x squared. So this is really this. X squared plus 1. And this is really 7x squared minus 8. Now you do need to check to see if either of those factor more, because it's a quadratic. We already know this one doesn't factor. It multiplies to be 1 and adds up to be 0. Nothing, because one of them would need to be negative. That doesn't work over here. What multiplies to be negative 56, a times c, look, a times c or b is 0, nothing. 7 and 8 is 1. You guys see what I'm saying? So we are done here, but there are some on the homework where they continue to factor. All good? Okay. All right, we're almost done with the lesson here, and then you can practice. So any suggestions here? Isn't it quadratic in form in a sense? Okay, so you're saying, any suggestions? How could I rewrite it? Yeah.
You can write it as u squared plus 0u.
Yeah, we could.
Well, minus 25.
Yeah, we could, absolutely. Or we could just go u squared minus 25. I like both of those. I like that. So do we know how to factor that?
Yeah.
Two perfect squares, isn't it? Or we could do what multiplies to be a times c, what multiplies to be negative 25, and adds up to be 0. 5 times negative 5. True? So this factors to be, yep, you're right on, sir. U plus 5, u minus 5, and then we'll re-put it in. U was actually what?
X squared.
Yeah, x squared, which we didn't write that. I highly recommend that, because that was actually x squared squared, just so everybody knows on the video. So x squared plus 5, and x squared minus 5. And neither of those factor either more. There are some on the homework that do. Awesome. You guys get it?
Yep.
Sweet. Okay, now the rest of the time is yours till the bell rings. You have about 6 minutes to do as many as you can in class. The rest is homework. Way to go.